Consider a set of 5 numbers that needs to be sorted. The way selection sort works is that we select the first minimum value and place it at first position. Then select the second minimum value and place it at second position. Select third minimum and place it at third position, and we do this 5 times. So to generalize, for the ith iteration, select the ith minimum value and place it at ith position. So the first minimum goes to the first position, second minimum goes to the second position, third minimum goes to the third position, so on and so forth. But how does selection sort actually do this? Consider iteration 1, where the aim is to find the first minimum value. We begin our iteration assuming that the element at position 1 is our best candidate so far. But we need to be certain, right? So we look at other values. Is 5 the best candidate? No. Is 1 the best candidate? Yes. In this case, we update the position for our best candidate. But there are still more numbers to look at. Is 2 the best candidate? No. Is 3 the best candidate? No. And there are no more numbers to look at, so we can be certain that 1 in fact is the best candidate for iteration 1. What do we do next? We replace it with the element at first position, placing first minimum exactly where it needs to be. Now consider iteration 2. The aim this time is to find the second minimum value. We begin our iteration assuming that the element at second position is the best candidate for our search. But let's be certain. Is 4 the best candidate? Yes. Update the position for best candidate. Is 2 the best candidate? Yes again. Update the position for best candidate. Is 3 the best candidate? No. And there are no more numbers to look at, so we can be certain that 2 in fact is the second minimum value. What do we do next? We replace it with the element at second position, placing second minimum exactly where it needs to be. Iteration 3 begins with the same assumption, that the element at third position is the best candidate for our search, and we look to the right. Is 5 the best candidate? No. Is 3 the best candidate? Yes. Update the position for best candidate. And with this, there are no more numbers to look at, so we can be certain that 3 in fact is the third minimum value. What do we do next? We replace it with the element at third position, placing third minimum exactly where it needs to be. The idea for fourth iteration is again the same. Assume element at fourth position to be the best candidate and look to the right. Is 4 the best candidate? Yes. Update the position for best candidate. And there are no more numbers to look at, so we replace fourth minimum where it needs to be. For the final iteration, we assume fifth element to be the best candidate, but there are no elements to look to the right. So this assumption is always true, keeping 5 where it is. And with this, our numbers are sorted. Easier than you thought. Well, the code for selection sort is much easier. Consider a function selection sort with the array itself as an argument. Remember, for 5 elements we performed 5 iterations, so the number of iterations this time is equal to the size of our array. We do this by looping over the length of the given array. And in ith iteration, we assumed that the element at ith index is the best candidate for ith minimum value. That is, best min index is equal to the I itself. But we need to be certain, right? So we look at other values to the right, starting from position I plus 1 all the way up to the last element. And if it ever occurs that the current value at position j is smaller than the value at best min index, we update the position for our best min index. And once the inner loop ends, we can be certain that the best min index holds the position for ith minimum value. What do we do next? We swap the value at best min index with the value at ith index using a temporary variable. And with this, we place the ith minimum value exactly where it needs to be. And that's all for selection sort. I hope the video was helpful. Thanks for watching.